Hello, and welcome to the Wednesday, September 12th edition of the Cluster API breakout meeting for SIG Cluster Lifecycle. Hopefully, the people that are here have figured this out, but at the top of the agenda, I put that we have a new Zoom URL. As part of sort of adhering to the community standards with Kubernetes, Paris has been pestering the SIG chairs for various SIGs to follow the new procedures for how we use Zoom, which gives us improved moderation capabilities. And what this means is that each meeting is going to have a different URL. And that we should not be sharing those URLs on public websites or social media. They should be sort of just kept within the Kubernetes community. So the URL for the meeting you're trying to join should always be correct in the calendar invite and at the top of the meeting notes. So if you're watching this video on YouTube and you're trying to join a meeting in the future, the best place to look is find the meeting notes for the meeting you want to go to and go to the top of that doc and join that meeting. All of those documents should be kept up to date. Because it's possible that we're going to have to cycle through different URLs over time going forward. The URL I created for this meeting, I believe, lasts for like a year and a half, but Zoom wouldn't let me schedule it out farther than that. So I think it's sort of got a clock on when we're going to have to rotate. We might rotate sooner if the situation warrants it. So for those that were able to find the right place, thank you for showing up today. And the first thing I put on the agenda is to talk about the migration to CRDs. We talked about this last week, but Phil wasn't able to make it, partly because I forgot to tell him when the meeting was. But Phil was nice enough to join us today, and he can give an overview of sort of where we're at on the CRD migration, and we'll open up to questions. I know people had some questions last week that I wasn't able to answer all of.
Great. So yeah, I've been working with Robbie and Sunil on migrating the cluster APIs to KubeBuilder from API Server Builder. There's a lot of benefits to this that I can go into if you want afterwards. But the status update is that we got the code moved over. Sunil and I did a code review, and it looks correct from a review perspective. However, we know there's probably bits and pieces that are missing. We haven't even looked at stuff like migrating the tests over or make files or various other pieces, updating docs or this sort of stuff. We've really just focused on the controller code and the types code. The type code was pretty straightforward. Not many changes were required. The biggest change there is that the validation and the defaulting, we are disabled right now. So the code is kept in, but we need to set up webhooks to enable all that stuff. The controller code is more invasive. It's mostly deletions, and it's mostly collapsing a bunch of either scaffolded code or generated code into a single library call. So for instance, currently there's a bunch of code around like setting up queues and setting up informers and these sorts of things. And all that is now just hidden behind an abstraction layer. Things like traversing and finding parents and then re-enqueuing a parent based on a child object change and this sort of stuff is also hidden behind an abstraction layer. You don't need to manually do any of that anymore. The other big change is the client shifted from a code-generated client to a client that is dynamic based on the type passed in. This makes the overall structure of the code a lot cleaner and allows us to do dependency generation or dependency injection actually in a simpler way, so that the various parts of the project have access to a client and can read and write arbitrary objects without you having to like rewire in a generated client every time to every component. That client by default reads from the cache, actually, which does save some logic. Like there's different parts where you have to remember to like deep copy when you read from the from the lister's cache and this sort of thing. And so you don't actually need to deep copy anymore. That is automatically done for you. We do need to give a close look at the code to make sure that in places where we shifted from reading live from default to reading from cache by default, that is something we actually want to do. And if we don't want to read from the cache, the client can also read live. You just need to pick a different client. So those are my updates. And the week after next, I'll be going to Seattle to sit next to Robbie and then try and pair out together a final version that's rebased to resolve all the conflicts, and that we've kicked the tires hard enough that we are pretty confident it looks good. Questions?
I think before we dive into specific questions, you mentioned there are lots of benefits. I assume you covered at least some of those in terms of like cleaning up the client code and so forth. Maybe like it would be useful to people to give a couple of the other like higher level benefits. I know part of the reason from our side we were looking at doing this was that we were using the API server builder code, and I think it was generating compatibility with Kubernetes 1.9, and people were like, well, when can we get the newer versions of Kubernetes, right? So I think from our point of view, that was one of the big benefits, is like it allows us to stay up to date much more easily. But I'm assuming from your perspective, having worked on both of these two libraries we've been looking at, there's some other sort of big things we should know about from the plus side, and then maybe we can also talk about things we might be losing as well.
Yeah. So some history, I created API Server Builder 2 years ago as a pet project without any intention of ever supporting it for any real use case. And I stopped even looking at the repo, I don't know, probably 9 months ago. So from a support standpoint, whereas KubeBuilder is something that came out of API Server Builder, and the KubeBuilder as it is today is at a 1.0 version where we've built on experience of early versions of KubeBuilder, and I'd say it's at its third iteration. And so we've, from perspective of building the infrastructure that you're using, it's a much more stable, well thought out, extensible platform. We learned about how certain things like breaking version compatibility. With API Server Builder, the way we thought we were going to do that was through generated code. And generated code is actually hard to debug. It's if it just works and you never need to touch it, that's great. And if you need to touch it, it's like incredibly brittle, and it's worse than just copying and pasting, right? So shifting away from generated code, for instance, to libraries, and then writing those libraries in such a way that we're unlikely to break version skew. So for instance, by returning structs where we can add fields to them instead of having to change the method signature, or even for functions that don't have any configuration, taking a struct argument of optional fields so that when we discover, hey, I'd really like to configure this with this foo flag, right? We can add those in without breaking everyone and making them rebase. The API Server Builder code, the controller code was copied from actually the service catalog. Controller code was written, which was written a long time ago, and has no issues in it that we've discovered and since fixed. Like for instance, one is I think we do a delaying in queue every time that you re-enqueue an object instead of only doing a delaying when there's an error. And so one user, for instance, found out that when they had to re-enqueue a bunch of objects intentionally, that they were getting this exponential back off, which was causing their system not to function as they wanted. So there's known bugs inside the API Server Builder controller code that you probably won't hit while you're in EAP or alpha, and maybe not even beta, but then when you hit GA, you're gonna be like, oh, we've now stressed the system enough to realize that there's issues in here. And again, it not being supported and not having, being on the latest code and this sort of stuff means that you're gonna suffer if you're built on it. So that's some of the stuff, like you might not notice this today, but a year from now you won't be in a really bad position, right? Some of the stuff where I think you can appreciate today is the code. We've tried to simplify how we set up the project structure quite a bit. There's not this extra tool that you need that runs code generators, for instance. All the logic is built right into the project, and you can just do go generate. Like if you look at the make file, it's just go generate, go build, these sorts of things. And so like the only code generator you need is the deep copy generator, which is actually vendored in, so you don't need to download this extra binary. The make file runs go vet for instance, on your code, which means from day one, you don't start introducing errors. Like, as part of the migration, GoVet actually found a couple issues in the code. Some of them were like just things that didn't matter that much, like, hey, you don't need to declare the type of this variable because it's like implicitly defined, which is not that big of a deal. Some of them were like, this variable is actually being masked and you're not returning the value you think you're returning, which we actually did fix. So having that in, let's see. I think that's most of the main stuff. I think you'll observe a much simpler project structure based on minimal scaffolding and leveraging very flexible dynamic libraries as opposed to lots of code generation. Is that kind of the summary you're looking for there, Robbie?
Yeah, I think that's really great. I think when I think about the potential downsides of not running our own API server, the things that come to mind are the things you mentioned that were sort of removed today, which is validation and defaulting. And in particular, we'll probably get into this a little more in the next section, but right now we can do that validation and defaulting in our client libraries for the provider config raw extensions. And I think that's something that we lose using KubeBuilder, because that's all done on the server side with webhooks.
Yeah, wait, so why can't you do it client side anymore?
I think we're getting it sort of for free client side because we were using the same codecs and the same sort of generated libraries on the clients, like in our controllers that were being used on the server.
Okay, I probably want to know more about that and what those use cases are.
Yes, that was the next thing I put on the agenda. So we'll talk about that in a second. I want to make sure if other people have questions. I think there were maybe some questions last week about KubeBuilder or CRDs in general that people might want to ask.
So do you guys have a list of things that that people who are working on vendor specific actuators should be prepared for?
You mean changes?
Yeah, changes. How would this affect? Yeah, how would this affect the vendor specific providers?
So that's what I started working on. Is I've got a branch of the provider GCP repo that is vendoring in Phil's branch of the upstream cluster API repo, and trying to figure out like what the ripple effects are to use the one that's switched to KubeBuilder and using CRDs. So I've started working on that. I've got it compiling, but I'm not convinced it's actually running and working successfully end to end yet. And part of the reason for that exercise is before we make this change in the upstream repo, we want to understand what the downstream implications are, what things have to change in the provider-specific repos, how disruptive that is, and verify that, at least for one, we can actually make it work end-to-end with real actuators. Because we don't have any real actuators in the cluster API repo right now that we can test. So like, for example, like the first time I tried to vendor in the upstream repo, I found out that like, Phil had left cluster cuddle in there, but it didn't actually compile and was still referencing old libraries because like it wasn't in sort of like the place that the makefile for KubeBuilder was expecting it to be, right? And so like there are things like that we don't find until we try and test it in one of the repos with an actuator. Yeah, and so I started working on that last week. I haven't made as much progress this week, and I've got a ton of other stuff going on. So I think what's likely to happen is at the tail end of this week, I'll be able to pick that work back up, and then get it to a point where when Phil is here in a couple of weeks, we can, like you said, sort of finish getting the story working end to end, get the test cleaned up, make sure that we have a good understanding of how we want to do the multiple pieces, and then kind of come back to the group after that. Or if people want it to help during that process, that'd be great also. And sort of lay out, here's what it's going to look like to migrate and verify that everybody is still on board. So I think part of the reason we started this process is because everybody was theoretically on board with, we think this is a good idea and a good strategy. And I think that's part of the reason I also wanted Phil to talk about the benefits, is because we are going to see an awful lot of churn in the main repo and an awful lot of churn in the provider repos during this migration process. And I want to be clear on this is why we're doing it. Like there is a light at the end of the tunnel. We are going to have some really good benefits as a result of doing this. Other questions about the work in progress PR? I don't know if anybody's had a chance to look at it yet. It's a pretty big delta.
Yeah, I wish there's a way to do it incrementally, but there's not a great one.
Okay, if there aren't any other questions, I'll start talking about the next thing, which is the GCP specific repo. So I'll mention that the first thing that I tried to do was just vendor Phil's branch directly into the existing code, and that really didn't work. It sort of got me into a state where GoDeps at one point was in what I think was an infinite loop. I stopped it after it ran for upwards of 30 minutes, and it was doing the same thing over and over. So maybe it would have finished, but it appeared to be infinite for all practical reasons. So what I ended up doing was the same thing that Phil did, which was I started effectively a new KubeBuilder repo, following sort of the KubeBuilder niche project structure, and then moved our code into sort of where KubeBuilder expected it to be. So things shifted around a little bit. Like right now in the GCP repo, there's the cloud directory at the top level. Like I moved that underneath package because KubeBuilder likes to compile all of our code under package. I moved cluster-cuddle from a top level directory underneath command because that's where it expects to run go vet and so forth for the command code. And like I said, I have that compiling. I have it running cluster-cuddle. I can use it, and it's I think almost creating a cluster. It's spitting out some errors that I haven't had a chance to debug. But again, like the change in the main repo, it's a pretty big delta because it is sort of switching the way that the project, the repo is structured from the structure that we built around with the API server builder to a structure we built around with KubeBuilder, and those look quite a bit different. The other thing that I wanted to mention was, as I was going through this process and trying to figure out how we want to marshal and unmarshal the provider configs, which right now are inline raw extensions that are other API types in YAML. I took those types, which we previously used API Server Builder to generate deep copies and so forth, and ran KubeBuilder on them, and now KubeBuilder generates them as CRDs. And sort of what I was alluding to earlier was having these CRDs embedded as to strings as a raw extension inside of the machine object means that we lose some of the benefits of them being CRDs. Like we lose the benefits of having the server be able to do the webhook validation and webhook defaulting. We lose some benefits of having automatic conversion between different versions and having really an easy story for client and server and controller version skew. So I can imagine a scenario where we could have, you have your doc about getting started, and it tells you to embed, a v1 alpha 1 GCP struct inside your machine, and you post that to the server, and then the controller pulls it down, and the controller has been compiled against v1 alpha 2, and it can't parse the embedded structure anymore. If we're using CRDs, what would happen is, once versioning is implemented, which it's not yet, but the client would post the v1 alpha 1, and the server side would actually convert that via webhook to v1 alpha 2, because the controller asks for a specific version of that resource, and things would continue to work across versions. And that would give us a way to sort of easily move things forward. I'm a little bit concerned with embedding it that we are not going to have easy facilities to move things forward. So that was, again, something I hadn't talked yet to Phil about, and I was wondering if you had any thoughts about that. And not, if you don't right now, I don't want to put you on the spot. We can chat about it more. But it's something that Chris Rousey and I were talking about, and starting to get a little bit concerned with the way we're doing embedding.
Yeah, I think I need a whiteboard to tease that one out more.
I don't know if anybody else who's on the line has looked at the types and has thought about this problem or something related, then wants to say something. Okay, maybe it'd be useful for me to write up a quick summary. This is still sort of coming together in my head as to sort of what the problems might be down the road and what we might be able to do about it. But I did want to mention it, see if anybody else has run into this edge case in their thinking or maybe in practice using CRDs elsewhere, and might have some experience we could draw upon. So I will take an action to sort of write that up for next week. Hardik?
Yes. So if I understood correct, if it's specifically about the provider config, right, when we will move it out to the machine classes, maybe in that cases we will be having much more freedom, right? So at the moment, if it's inline, then this defaulting out could be a problem because we have multiple versions across for the machine and provider config. But if we have it outside and we know that the machine class is equal to provider config at much larger extent, then we can maintain the same API version then, and then we can make use of such features, right?
Yeah, and in that case, I also worry about a future where if you are allowed to both inline it and put it in the machine class, that you might have examples that work if you put it in machine classes where we do get the defaulting and conversion behavior, but that break if you try to inline it, which I think is also, you know, a user experience we don't want to have, where like if you use the system in quote the right way, things work, and if you don't use it in the right way, like we don't provide any sort of graceful degradation or guardrails to prevent you from shooting yourself in the foot. Because the whole point of inlining it is it's supposed to be a better user experience. And if that becomes a really dicey user experience because half the time it works and half the time it doesn't, then that is, you know, a strictly worse user experience.
Yeah, that's correct. The experience will actually differ in both the cases. Then we might want to have a de facto way of doing and have a suggestion that this is the way of providing the provider config, whether it's inline or machine class. Or
yeah, okay. So I'll take an action to write that up, and I'll try to send that out in advance of next week's meeting so people have a chance to look over it and we can maybe discuss it in more detail at that point. The next thing I had on the agenda was machine classes. So Hardik sent a PR last week. We discussed it briefly last week. It's gotten a couple of comments on it. I wanted to circle back and have people take another look at it. I know that I think Martin added a couple comments to it yesterday, the day before. I don't think he's here on the call though. I guess so. From your perspective, Hardik, what is outstanding before we can set a clock and get that merged?
So from my perspective, so we have instantly not added a lot of fields which would required probably for cluster autoscaler or other outside out of the box consumers, right? So it's first cut where it's more or less equal to the provider config, but in the subsequent PRs we will try to include more fields which will require probably much more discussion, like allocatables and capacity and other stuff. So it's at the moment it's only about externalizing the provider config. So I don't see anything outstanding as such as of now.
Okay, so I think maybe the path forward there is we should resolve the existing comments and give people, you know, maybe like another day to add more comments. I'll put a hold on it, and if people want to take a look, we can LGTM and approve it, and then we'll remove the hold in about 24 hours and let it merge. And then Phil, that'll be one more API object that we'll need to pull into KubeBuilder when we rebase. So I think you're right now about four or five commits behind head.
Okay, we can do one more.
It should be a pretty easy one.
Yeah, I'm not worried.
Cool. All right, so I'll put some notes to that effect in our meeting notes. Abeltor, you've got the next item here. It looks like you're linking to issue number 497.
Yeah, it's about the dynamic link and reconciling between machines and nodes. So mainly, if you look at the code today, the way that this is happening is, so it is relying on setting an annotation on the node to match a given machine name. So I think ideally this should happen dynamically. So basically, some controller should be able to reconcile the node resulting from a given machine as soon as it comes up. So one possible option for this to happen would be to use something like the IP of the machine. So match both the nodes and the machine using the IP. So basically, I think I like to have two discussions. Like one is if we all agree that this should happen dynamically, and the second one is about if the IP is the best way to do this.
So I agree that it should happen dynamically. I don't know if IPs are the best way to do that. What do we not like about using, well,
Okay.
I would think we would use selectors, right? Or am I not understanding the problem?
So
Oh,
from my yes. So I would say the problem is essentially about mapping the node and machine, right? How to first problem is how to uniquely map a node and the machine, and I guess the second problem is whether we want to really allow the node to be replaced when the machine object remains the same. That's the second question that we need to think about. But for the first part, I guess each cloud provider anyway provides some kind of unique identifier for the machine. For example, when you do a create call on the AWS, you get the instance ID back, that what's the instance ID from the machine. For GCP, Azure, and so on, whenever you try to create, you already have a control on the name of the machine, which is also the unique identifier for the machine's name on the cloud provider, so that there would not be conflict there. So what we could do is that on one layer of mapping, for instance, for AWS, let's imagine that on the machine object, we will have to refer to the instance ID of the actual node created, and we should just refer. So what we do actually in MCM is that we have the provider ID. If you see the node object, you will find a field called provider ID, right? And the provider ID is a field which contains quite a good detail about the cloud provider. It says which region it runs in, which zone it runs in, and what's the exact instance ID. So we take that one provider ID out of that node object and put it on the machine object. So that becomes one way of clear mapping that this machine is for this particular node, and that pretty much suffices. And on top of it, we could have one field which we, I guess, anyway have in the machine status is basically node reference, right? So the node reference anyway will have the node name which Kubernetes control plane understands. So for many providers, this might not be the case, but for AWS, you will see that the node object is mainly the private IP following something and so on. And then you will also see that the actual machine is instance ID and the real name of the machine could be different, right? So that's how at the 2 layers we can solve it. But the second question remains, where do we really want a behavior when I create a machine object, I expect the node object to be attached to it, but then in future, a completely new node object could be mapped to the same machine object I have. Or we should have a cleaner approach where if my node object is missing, I should get rid of the machine object and expect a new machine object to be created which maps to the new node object which is supposed to be there. So I would prefer the later one, just to avoid the confusions at the controller level that which node this machine object belongs to. So basically the mapping should happen only at the creation time. That you create it, it's in the pending state, you get the necessary information of like the provider once node object registers, get the provider ID, instance ID, and so on, and then get the node name of the node from the Kubernetes control plane and make it the only truth of the knowledge on the machine object. And if something goes wrong, then get rid of the machine object and get a new machine object.
Do nodes, when they're like the kubelets posting node status, present that instance ID, for example, on AWS, such that you can map it over? Or like, how do you, I can see like your actuator, it says, create an AWS VM, and it gets the instance ID back, and you stick that on the machine, and now you're storing that. But when nodes start showing up and joining the cluster, how do you then know which one is using that instance ID? Is that reported back by the kubelet?
No, so kubelet does not really report back. I mean, in the node conditions, you will not see the instance ID as such, but the machine controller, where from the list it gets to know from the cloud provider, with this instance ID is mapping to this particular machine.
But how do you get to the node?
There is a field, there are two fields. There's internal ID and external ID, I think, on the node. Today, those are populated by the kubelet, but I think that may change with the sort of move to like doing things centrally. I'm not sure how the matching will happen securely in future, but there is that field, which I think is on all platforms. External ID is the non-deprecated one.
Yeah, I mean, I guess it sounds like maybe the other option Hardik was saying was when a node joins, you can go and query, the cloud provider API to figure out which one that is? Like, does that actually work? Can you actually tie it back correctly that way?
So basically the mapping, the population of the information should happen only when the create call is done, right? So if create is successful, the machine is created, you get the instance ID and the entire string of the provider ID, which has all the information inside it, and you put it on the machine object. That's the only way you would want to modify those information on a particular machine object. Now, if machine goes down, it reboots, there's a network connection, whatever happens, the same machine would again respond back, and the node object, if the node object is registered or if it's gone, if the node object is gone, then there is a different problem. Then we have to think about the orphan VM cases. But we would expect that the node object would be registered either ready or not ready. So based on the node object, we don't need to really think about the cloud provider APIs at that moment. Only in the orphan VM case, we need to think about the cloud provider API, that whether any VM is really orphan and the related machine object is not available.
Yeah, I guess the connection I'm not understanding is you get that instance ID when you create the VM and you put it on the machine. At some later point, a node shows up and registers. And how do you know it's like, you create 10 in parallel. How do you know which node that shows up you link to which machine, if the nodes aren't themselves telling you what that ID was?
Yes, so when the machine is created, right, the corresponding node object will be registered on the Kubernetes control plane. And from the machine controller, you can identify that which node object has, so in the node object also, you will see that the instance ID would be mentioned.
That's what I was wondering, is if that's reported back by the node.
Yes, so if the kubelet is installed in any of the machine, kubelet will by default give you the information, what's the instance ID and so on. And that node object will help you connect it to the actual machine object.
I think, Siddharth, it looked like you were trying to say something too.
Yeah, so one additional thing I can think is, like, since we're using kubeADM to join these nodes, one thing we can do is add an additional config option in the kubeADM itself to specify, add a label to that node when it's joining in with the unique ID of that cloud provider itself. And that could be part of the init script of that node itself. So that way, whenever a node, it kind of becomes the part of the template, for example, that kind of pushes in the init script altogether inside that node to put it out. So,
I think that's kind of equivalent to what we're doing today with annotations, right?
Yeah, but this would be, so this would probably be more as the node comes up, and since the provider specific thing is responsible for creating whatever the script is that kind of joins that thing, so it's not controlled from the provider. So provider can inject whatever the unique identification which is specific to that provider, can add that as part of the node joining mechanism itself. So that way it becomes a little bit more easier to tie it down later. But yes, I mean, so this is just on the point of how do we kind of potentially link the two, number one. Yeah, that's essentially on that. I mean, I had one more additional point to make on a side note around the same topic though, if it's okay if I can make that point.
Yeah, go ahead.
Okay, all right. So one of the things I noticed is in the node, today in the code which we're doing the node linking, it's made an inherent assumption that the nodes that you're looking at is in the same, so the cluster API is running on the same target cluster itself. That means the pivot has happened and now you're all in the same ecosystem of the same Kubernetes cluster, which is okay. However, now in the case where, for example, where you don't want to do pivot and you want to do a kind of a remote management, right? So you have one single cluster where you're running cluster API and you're just spinning off n number of target clusters. Now in that case, that piece will not, I mean, that assumption will break and that doesn't work. I mean, essentially, so any thoughts around, I mean, can we do something about it or is that even not even maybe a valid use case, or maybe we want to handle it differently? Just want to know some thoughts.
So I think that is a valid use case. That's actually why I kind of like the annotation, because it can refer uniquely if you have a name and a namespace, it can uniquely refer to a machine in a remote cluster. And similarly, I think you could do the same with a node, although you don't need a namespace to refer to the node.
Yeah, we had a discussion a little while back about creating a strong link between nodes and the cluster objects. And maybe I'm conflating in my head that link versus running it remotely for remote management. But that was one concern I had about if we stuck a reference from a machine to a cluster explicitly, that it would sort of become impossible to do this remote management scenario that you're describing. And maybe it's not, maybe it's just about where you run the controller, and you'd still put those two objects in the same cluster and it would be fine. But I think we need to understand what it would work in how it would work in that deployment scenario.
So if I remember correctly, there was one proposal, or at least some discussion that I remember from one of the previous SIG meetings, where the point was, should we want to, for example, say replicate since for remote management case specifically, it's going to be difficult to say, from your source Kubernetes cluster or bootstrap Kubernetes cluster, kind of constantly try and manage and monitor, for example, the nodes object on the remote clusters, and then try to kind of keep that sync. And I think the proposal or the idea was, can we copy over, let's say, some of that information and bury that inside the machine object, so that, in case if there is a disruption in between, at least, it's not completely, the system doesn't go off rails altogether. So it's kind of that. So one of the things is, I noticed, like, if we were to implement, for example, anything with the remote thing, we need to a way, for example, in our cluster API to kind of symbolize, are we running this cluster controller like inside the cluster, like inside the very cluster it's kind of managing? It's like a self-managing one, or is it not? Or maybe this is not maybe at a controller level, but it's maybe could be a cluster level thing that somehow you could maybe like add a bit piece of information on that cluster level object to say that, okay, this cluster, by the way, is the very cluster where you're operating on, so that then things can be handled slightly differently, especially when it comes to connecting to that cluster to manage or monitor its object, as compared to, because this cluster may also manage some other external clusters. So you kind of have to have a distinguishing way, and maybe a possible option could be add that a piece of information at the cluster to say this is a self-managed one. That means, the controller knows that it's where it's running also. It can make certain assumptions around it.
That makes sense to me. Anybody else have thoughts about that? Okay, so to pop back up the stack one level to Alberto's question, it sounds like, I'm just trying to read through your issue on 497, and it looks like Derek put a comment there about a specific use case, which I think is really valuable, because if we just say we don't want to have this link, like it's hard to say why or why not. So I just want to read Derek's use case here that he's stuck on there this morning, which is, you create a machine that creates a node. The node appears in the API server without a role label, and the machine controller can assign a role label to the node, so that the labels are assigned not by the nodes themselves, but by controllers. And this is in line with a proposal that Mike Denise made a while back about taking away some of the power of things running on the node to self-label or to self-taint, because we don't want nodes to be able to steer workloads to or away from themselves. So I think maybe also sort of grounding the conversation in specific use cases would be nice, so we can talk about how the current implementation maybe doesn't work for that use case, and how a proposed implementation sort of does work for that use case. So I guess, Alberto, back to you. It sounds like if we move away from the annotations, what's the alternate proposal for how we want to dynamically link the node in the machine? So it sounds like one thing you said was by IP.
Yeah, so that's what I basically wanted to validate with you guys. Like, again, main thing is to make sure that we are aligned and that we want to do it dynamically. So if that's the case, I don't know. I guess that the path forward would be to keep investigating the best way to doing it, and maybe I'd be able to come up with a PR so we can discuss about it, or I don't know if that makes sense.
Yeah, so I think, David, you mentioned that you're concerned about matching by IP. Can you expand a little bit on that, about what you think would be a problem with using IPs?
Well, I mean, I suppose in some ways, IPs are unique within a given cluster. So you could still match on IP. I guess IPs seem like an implementation detail that I don't know that all providers want to expose. On the other hand, since we're talking about the link between a machine and a node, every node has an IP, so maybe I don't object.
Well, I guess if it's a gut feeling, that's fine too. Like if you say, like, my gut is telling me that this is maybe not the best thing to use, I think that's a good thing for us to consider, right? And I was trying to figure out if it was more of like a gut feeling, like I feel like this is not great design, or if it's like I have a specific use case where this definitely won't work. Because I think, you know, we should consider those differently, right?
So one potential issue with the IP matching, though, that I see is if you have a use case where your worker nodes, for example, you want multiple NICs on them. I know, I mean, that's something, for example, for our use case, we probably need that. So essentially, the moment you introduce multiple NICs, now it's going to be very confusing to say, okay, which IP are you talking about and how do you map, and whether those multiple IPs are properly reported back, for example, even from the cloud provider side. It becomes a little bit more confusing to say, how do you match those up, especially if you have multiple NICs. That could be one challenge at least.
So we actually did run into that problem with our SSH provider. Once we started using it against cloud instances with multiple interfaces. So.
You guys find a solution to that problem, or did you work around it a different way?
What we did is embarrassing, but we knew what the IP address we wanted to use for SSH was, and we just assumed that that was the one true address. I don't think, I mean, for SSH, you need to have a way to contact the host. For other providers, you may not need that at all, right?
And just to add additional confusion around that is, like, for example, think about a system like OpenStack, where you can have a machine instance that you create with an internal IP, and then you can add dynamically a floating IP to it. And the floating IP does not really show up on the node itself in any shape or form. However, for example, that floating IP is actually what you actually would need to SSH, for example. Especially consider the case where you have a bash and host in play. Your entry point is maybe just one machine with a floating IP, and then you're kind of reaching all the others. Well, I mean, maybe it's not exactly the specific use case here, but that's essentially one of the other things. You know, IP sometimes can be a little bit not add up as one would expect. I mean, I think my 2 cents here would be maybe we should look at like a tiered approach to say, try this option. If this doesn't work, then go to the next possible best option, and kind of do it that way to maybe come up with a little bit more tiered operation, and see how we can best match in a reasonable way the machine and a node. And that flow could involve certain steps. For example, a cloud provider implementation could do, so that would completely short circuit the other matching things. And that could be one way for individual cloud providers to run. And for those who don't want to add the additional metadata, they could fall back to a little bit more primitive ways. IPs could be one of them. That's maybe something that comes to my mind. So.
I agree. Since we don't have much more time, I wanted to eventually talk about machine sets. I'll defer that to next week. But along the lines of what you're saying, I think we do need to have the ability. Well, I think currently the reality is some providers operate remote clusters and some operate their, and sometimes the machine objects exist within the cluster for which they're operating. I think that interface needs to be made a little more clear, in particular for generic controllers. So right now, one thing I find troubling is we don't have clear expectations about whether a machine exists within the cluster or external to the cluster. And our API guarantees, I think, need to be a little more clear in terms of what does it mean to be, like, if you're going to operate externally, do you lose functionality from the generic controllers? I mean, will they work anymore? Or are the generic controllers only intended to be run within cluster? So.
I think this was one of the reasons that Hardik had proposed copying the node conditions over into the machines, is that if we put all of the sort of bridging logic, if you will, in one place in the machine controller, and all the generic controllers above that are not required to do anything except, you know, look one level below. So the machine deployments look at machine sets look at machines. The original implementation, machine sets looked at machines and nodes, right? So it was following the reference from machines to nodes, which meant that if those nodes were in a different cluster, it wouldn't be able to find them, right? By centralizing that logic in the machines and making the machines the only thing that needs to know whether nodes are local or remote, that means that the generic pieces above that don't have to care anymore. So I think that was one of the reasons for moving node conditions over, is that can give us health checking at the machine set level without the machine set needing to know where the nodes live or care, right? So then the question is on the machine controller, is the part that needs to be able to know those things, is that, you know, actuator code, is that the generic quote unquote machine controller code that we want to reuse, and how aware does that have to be about where the nodes exist? But I do think that, you know, ideally the stuff up higher in the stack wouldn't be relying on that fact necessarily. I mean, it also, right now we have like a reference in the machine status to the node object, and that was sort of put there assuming that it was in the same cluster. I think that there is a reference type in Kubernetes that might allow you to reference something in a different cluster. I'm not sure. I know there's like an object reference versus a local object reference. I don't remember if that's same cluster, same namespace versus same cluster, or if there's a way to put enough information in there to actually indicate that it's in a different cluster, and you know, assuming you have credentials, which cluster that might be. But it might be worth exploring, making that node reference a little bit more expressive. Because then, you know, even if we don't expect higher level tools to do it, you know, if a person was looking at a machine and they see a reference, they're going to want, you know, maybe to go inspect that node. And if they see a reference to something that just doesn't exist, it's going to be pretty confusing. But I do think it would be good to you know, maybe go back to like the KEP. I haven't updated in a while, but go back to the KEP and sort of flush out some of the different scenarios that we expect to support. I think that's kind of maybe what you're getting at the root of your comment.
I would actually support the statement of some kind of short circuiting for the cloud provider specific thing. And if node object itself has something very unique, so there is a field called provider ID which just tells you, which very uniquely identifies a machine on the cloud provider. It tells you everything that needs to be known to identify the exact machine. Then why not just get that guy out and put it on the machine object?
Okay, we have about 3.5 minutes left. Hardik, I saw you have the last thing on the agenda. Do you want to at least introduce the topic, even if you don't have time to have a lengthy discussion about it?
Yes, so I'll just put 1 or 2 liners. So I just want to reinitiate the discussion on the machine phases and the states. So it was discussed, I guess, some time back when we were on the previous repository, and there was quite a good discussion there. So I will just take the work from there on the machine states and phase, and just wanted to confirm if anyone else is on it, we can maybe collaborate, or just want to convey that I'll be starting on it from now. If you have any suggestions or anything, we can get connected. Because in my opinion, that's next chunk remaining in the machine API that we need to take care of. That's pretty much all, actually.
Okay. And for people that don't remember, a quick overview of what those are. Machine phases and states is effectively a way to indicate some bits about sort of the life cycle of the machine, where it is in sort of the overall life cycle of provisioning, running, updated, et cetera, split across 2 new API fields. There is some overlap with the document that Philip and I shared around at the beginning of this year about sort of the managed machine lifecycle. I think they're somewhat close, but there's a little bit of convergence we need to do between the 2 concepts, and make sure that we agree on what those are. There are also some comments on my doc from Tim and Daniel Smith that we need to be really careful about whether or how we encode state diagrams into our API, because they've had bad experiences doing that in the past. And I think that the way that the phases and states does it might be a little bit more elegant than what I'd been proposing. And so I would encourage people, if they're interested, to both look at the doc, which I haven't updated in a while, but is still relevant, and also, as Hardik said, the discussion about this in the kubedeploy repo. And if you don't want to go find it there, I think he'll pull that discussion and comment thread over into the new repo too.
Is there a link to the previous discussion that you can add to the Google Doc that might be helpful?
That was for you, Hardik. Can you, if
Yes.
you don't have to do it right this second, but if you can stick it in there so people can find it easily, in the next.
Yes, sure. I'll put that thing into the doc.
Cool. Thank you. All right, and with that, we are just about out of time. Anyone have anything else they wanted to finish the last 40 seconds with? All right. In that case, thank you everyone for coming. I'm glad to see people were able to find the new Zoom channel. And thank you, David, for being the moderator and letting everyone in as they tried to join in the waiting room. And we will see everyone at the next meeting. Have a good week. Take care.